Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to understand complex numbers and how they are typically represented, how to plot complex numbers on the complex plane, how to find the conjugate of complex numbers, and how to simplify complex numbers and perform mathematical operations on complex numbers. How are we learning it? Through the don't put Descartes before the horse notes and the don't put Descartes before the horse assignment. When can we use this information? To determine the amount of voltage being used in your house at different times of the year. How do we know we learned it? By getting a score of 4 on the don't put Descartes before the horse assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, I'll give you time to complete the don't put Descartes before the horse assignment on Desmos. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Complex Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the don't put Descartes before the horse notes. The notes begin with the learning goals and success criteria. Now, what is a complex number? A complex number is any number that cannot be found on the real number line. All complex numbers can be written as the sum of a real number and a complex number. So when we write it that way, it is called Cartesian form. So this is the standard form for writing a complex number. And it looks like this, a plus bi. Now a and b should both be real numbers. And then I obviously stands for imaginary. So we have our imaginary number here, and we can have multiples of them. So we could have 4i, which means there's 4 imaginary numbers. So we can look anything like this. A represents a real constant, B represents the real coefficient of I, and I represents the square root of -1. Now, from that, we can find a conjugate. So remember, the Cartesian form is a plus bi. The conjugate is always going to be the opposite sign of the bi part. So this would be a plus bi, so the conjugate would be a minus bi. Now if this was already negative, then it would become plus bi. So we always do the opposite. Now how do we write these numbers in Cartesian form? Well, we have here 3 plus 5i over 1 minus I. Well, in order for it to be in Cartesian form, the denominator can't exist. All right, we need to get rid of that denominator. So in order to do that, what we're going to do is we're going to multiply by the conjugate. So if we multiply both the top and the bottom by the conjugate, we end up with 3 plus 5i times 1 plus I, and then 1 minus I times 1 plus I. And when we do that, we should see that when we multiply this, 3 times 1 is 3, 3 times I is 3i, 5i times 1 is 5i, and then 5i times I is just -5. So we end up with 3 minus 5, which is -2, and we end up with 3i plus 5i, which is 8i. So that we end up with that. Then we do the denominator. Now notice this is really a difference of squares now. So when we multiply this out, we say this is really 1 squared, which is 1, and I squared, which is -1, so it's 1 minus -1, which is 2. So we end up with -2 plus 8i over 2. Well, we should notice that 2 goes into both of these. So when we do that, we get -2 divided by 2 is -1, and 8i divided by 2 is 4i. So we end up with -1 plus 4i. So anytime we're asked to find Cartesian form, we're going to multiply both top and bottom by the conjugate of the denominator. So now what if we had something like this? 3 plus 5i times 1 plus I. Well, all we need to do is just combine those and see what we get. So we get 3 times 1, which is 3, and 3 times I, which is 3i. Then we get 5i times 1, and 5i times I. So we end up with 3 plus 3i plus 5i plus 5i squared. Well, now we just combine like terms. So we have 3 plus 5i plus 3i plus 5i squared. And we get 3 plus 8i plus 5i squared. Now I squared is really just negative 1. So that's really 5 times negative 1, which is negative 5. Now we can combine these, so we get 3 minus 5, which is negative 2, plus 8i. Now complex number proofs. It says choose any two complex numbers, z1 and z2, and prove that the following statements are true. So we're asked if z1 plus z bar, and remember z bar means the conjugate. So we're saying that a number plus its conjugate and another number plus its conjugate. And we're saying that those are both real numbers when you add them up. So if we do this, let's check. So we have a plus bi plus a minus bi, right? Because all we're going to do is add the conjugates together. Well, we should notice that a plus a is left, and then we have bi minus bi, so those cancel each other out. So all we're left with is a plus a, which is 2a, and that is a real number because there's no i's left. So we were able to prove it that way. So that's true. Now let's try it for the second one. So for z2, we can say c plus di plus c minus di. And again, when we do that, when we combine these, the di's cancel out, and we're just left with 2c. So this was also true. So we can see that no matter how we do this, we're going to end up with a true statement. There's a video here that shows you how to plot complex numbers in Desmos. So go ahead and watch that video. Let's talk now about how we can plot complex numbers on the coordinate plane using Desmos. So what we're going to do is we're going to go to desmos.com and we're going to click on Graphing Calculator. And notice it gives us a standard graph, and we need to change this to become an Argand diagram. So what we're going to do is we're going to click on the little wrench here, and for my x-axis I'm going to label that RE for real, and y-axis we're going to label that IM for imaginary. Now we have our real and imaginary axes. Now let's say we were trying to plot the point 3 plus 2i. So let's say that's what we're trying to plot. Well, what we're going to do is we're going to treat the first number, the real number, as our x, and the imaginary number, the number in front of the I, as our y. So what we would do is we'd go ahead and put it in parentheses. We put 3, because that's our x, and then our y, which is 2, comma 2. And then we can label it, and now we have a graph with, this is 3 and 2i on the complex plane. So that's how you graph and check your work for plotting complex numbers on the complex plane. There's a video here that shows you how to check complex calculations using Desmos. So you can check to see if your conversion to Cartesian form was done correctly. So you can go ahead and watch that video. Let's talk now about how we can use the Desmos to check our work when dealing with calculations on complex numbers. So let's go ahead and go to the graphing calculator. I'm going to I go to desmos.com and I'm going to click on graphing calculator. And let's say that I wanted to add two complex numbers together. So 3 plus 3i plus, and then let's go 2 minus 4i. And I wanted to add those two complex numbers together. Well, when I add them together, I can do that, and I get 3 plus 2 is 5, and 3i plus minus 4i is negative I. So that's what I think it should be. So I'm going to just go ahead and put that in here for now. I think it should be 5 minus I. Well, we can check our work by putting it in coordinate form. So we have our 3 plus 2, comma, and then our second part, which is 3 minus 4. Right there. So all we did was place that in there. We added the reals, and then we added the imaginary numbers, and we placed them here. And if we label this, we see that it's at 5, negative 1, which is the same thing we have here, 5 and negative 1i. Now we could also do this with subtraction. So if we subtracted these instead, now we get 3 minus 2, which we think is 1, and 3i minus negative 4i, which we think should be 7i. Now we can place that in here. So this becomes 3 minus 2 and 3 minus negative 4. And when we do that, we know that 3 minus negative 4 becomes 3 plus 4, right? And now we can check our work. So we're going to go ahead and create a coordinate. So this is 3 minus 2, comma. And then we have 3 minus negative 4, which is plus 4, which is up here. And we can see that it's at 1, 7, which is exactly the same thing we got here. So this is how you can use Desmos to check your work when adding or subtracting with complex numbers. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the Don't Put Descartes Before the Horse assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that takes us to the Desmos activity. Go ahead and click on that link, and it takes us to a page that looks like this. We'll go ahead and click Start the Activity. The assignment begins with our learning goals and success criteria. We'll go ahead and click Next. And for this one, we're going to match each expression with its correct Cartesian form. So, for instance, we have this one here. It says 4 over 5i. So if we multiply both top and bottom by I, it should give us what we need. So when we do that, we get 4 times I is 4i, and 5 times I squared, which is negative 1 times 5, so that's negative 5. So we get 4 over 5i, which is this one here. So we're going to go ahead and grab it and drag it over and connect them. So we drag it until we see the little blue halo around it, and then we release. Now those two cards are together. And we're going to do that for each of these. And then we're going to go ahead and click Next and do it again on this page. So we're just going to match up the Cartesian form with its original form. So we will put the original form with its Cartesian form, and we'll do that for each of the questions. And then when we're done, we'll go back to our Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.